Hi, my name is John McGinley, and welcome to the CPL frozen tissue grinding tutorial. I'm going to talk to you today about how to make high-quality frozen tissue preparations for RNA and DNA extraction, as well as protein lysates. I like to have two areas for preparing the tissue, one for cutting and weighing, and one for tissue grinding. Here's a snapshot of the cutting and weighing area, and you can see a large styrofoam cooler over on the left-hand side. Looking inside the styrofoam cooler, you can see that the bottom of the cooler is filled with liquid nitrogen. Over on the right-hand side is a 3-inch white freezer box filled with uncut samples and heat seal bags. There's a little bit of liquid nitrogen in the freezer box to keep the samples cold. After I've finished cutting the samples, I'll take the residual tissue that's left over, put it back in the heat seal bag, staple it closed, and then put it in the very bottom of the cooler with the liquid nitrogen submerged to kind of keep everything nice and cold while I'm working on other samples. Over on the left-hand side, you'll see a 2-inch freezer box that has 2 mil tubes with the ground tissue. Looking at the cutting and weighing area in more detail, I have an analytical balance, small hexagonal weigh boats, one large plastic container, and one small plastic container. Both of these containers are made out of polypropylene. I have a rack with 4 50 mil polypropylene conical tubes, a pair of long forceps, a pair of small curved forceps, a pair of scissors, stapler, razor blade, and a tack hammer if necessary. Over on the opposite side is the tissue grinding area. Here I have a microfuge tube rack with 2 mil RNA-free tubes that have been labeled. I have a sample weight sheet for recording the weights of the tissue, a styrofoam microfuge tube rack that will actually hold the cold tubes as I'm pouring the tissue into the tubes, a metal dipper that I will use to dip out the liquid nitrogen from the styrofoam cooler and into the mortar and pestles, a pair of long forceps, a styrofoam lid to hold the mortar, and a styrofoam container that's filled with liquid nitrogen, and one small plastic funnel. The funnel I use is a 55 millimeter polypropylene analytical funnel that has been modified with a short neck. So I've just taken a pair of snips, cut the bottom of that off to leave just a very short piece of the neck, just enough to get into the top portion of the 2 mil microfuge tube. Here I am preparing the mortar and pestle for tissue grinding. So I'm taking my 2 mil tube, I'm placing that in liquid nitrogen to get cold, taking my metal dipper, and I'm going to put 2 dips of liquid nitrogen in the mortar with the pestle to get that kind of nice and cold while I'm working on cutting the sample. The funnel that I'm going to be using is also in liquid nitrogen, keeping all of those pieces nice and cold. I'm going to kind of twist the pestle around to get that cool, and I'm just going to let that sit there and chill while I'm working on cutting the sample. So now I'm going to show you how to cut and weigh the tissue. So here you can see I'm using one of the 50 mil conicals to pour some liquid nitrogen into each one of the containers. Now I've done this about probably 3 or 4 times prior to this for each container. In the beginning you'll have to use more liquid nitrogen obviously to get the containers cold, and then as time goes on you won't have to use quite as much each time. So here I'm just cutting the heat seal bag and using a small pair of curved forceps to get the tissue out of the bag and into the smaller container that I'm going to use to cut the tissue. And sometimes you kind of have to coax it out. There we go. All right. So now I'll get my weigh boat here, get that nice and chilled in the liquid nitrogen. So I'm going to take a razor blade and kind of cut off a little piece, a little chunk. and might have to kind of go back and divide that a little bit more. Get it into some smaller fragments to work with. Okay. I want to make sure that that weigh boat is nice and cold before I put it onto the scale. So I'm just going to let that cool for a few seconds. Okay, I'll dump out the excess liquid nitrogen, put that on the scale. We'll get a tare weight. And sometimes that takes a second or two to tare. Okay, there we go. And put in some more tissue here, see how close we're getting. So I'm working with liver samples today, and so I want that to be just under 30 milligrams. Okay, didn't quite have enough there, needed to go back, kind of, cool my weigh boat again, because things were warming up a little bit too much. I'm having to cut off a little bit more of the larger sample, get a larger fragment. And that's the thing, it's just, a little bit of trial and error, figuring out, what's going to be the right piece of tissue to use. And you want to make sure that you keep things nice and cold. You don't want to let it hang out too long outside of the liquid nitrogen because it will warm up very, very quickly, especially on that scale. And so here I go again, tearing the scale. And okay, so now it's ready. Pick up some fragments and get a good weight on this. Okay, we're getting closer, so I need a little bit more. And that looks good. Yeah, 28.9. So that's close enough. That's good. I just want to make sure that I don't go over 30 milligrams. So I'm going to put this back in the liquid nitrogen, kind of float that in liquid nitrogen, keep it nice and cold. Now I'm going to go back and grab the heat seal bag and put the residual amount of liver that I didn't use back in that heat seal bag, and then I'm going to staple it closed and put it back into the styrofoam cooler with the liquid nitrogen while I work on grinding this sample. So that's just about done. And yeah, throw in some staples, keep the tissue in there, keep it from floating out, and into the liquid nitrogen. So I'm going to start grinding tissue. I've already cut my sample. I'm bringing that over to the pre-chilled mortar and pestle and dropping that in. I'm going to add some more liquid nitrogen. Keep things nice and cold while I work on grinding the tissue. And just a couple of scoops. Okay. And here we go. So I'm going to use some slight downward pressure on top of the small pieces of liver that I've cut. And you don't want to start grinding right away. You want to start to kind of, break down those larger pieces into smaller and smaller chunks. And so I'm just kind of like working the pestle down into the mortar with those larger pieces. Now I'm starting to kind of grind those smaller pieces, get that into a nice fine powder. So I'm just going to kind of continue to use that motion and kind of check periodically to see how that's doing. It's going to take a little bit more to kind of get that all nice and ground up, make it, nice and uniform. Okay. Yeah, a little bit more grinding. Okay, now I'm running too low on liquid nitrogen, so I need to get a little bit more in there. So that's the most important thing. You want to keep things nice and cold while you're doing this. Otherwise, you're going to start to get degradation, especially if you're preparing samples for RNA. So I'm going to grab my tube. I'm going to, place my forefinger and thumb right up against that hinge and warm that hinge real quick before I pop the tube open. The reason I do that is if you don't warm that hinge first before you pop the tube open, chances are that tube cap is going to snap right off. So you want to make sure that hinge is warmed up a little bit just before you pop the cap open. So here we go. I've added a little bit more liquid nitrogen to the sample. Now I'm fishing out the funnel to place in the microfuge tube. I'm going to hold that there, kind of swirl it around, make sure I'm getting all of that ground sample, and I'm going to dump that right in the top there. And now I'm just going to take that out and tap the tube with the funnel, on the bench top, make sure that get all of that residual ground tissue that's in the funnel down into the tube. Now sometimes there's going to be a little bit of tissue that's left in the mortar, and so I'm just going to put a little bit more liquid nitrogen in there, swirl that around, and then dump that as well and tap it. Yeah, you want to make sure all that tissue gets down in there. Then I'm going to throw the funnel back in there, get that nice and cool, move that old mortar and pestle off the board. I'm going to let that evaporate for a second before I close the tube. Otherwise, it's likely to pop. You're going to make sure that you don't hold the tube by the bottom. Hold it by the top. Snap it closed, and we're done. Here's another view of tissue grinding looking from the top down. So you can see me pouring in some liquid nitrogen into the mortar. A couple of scoops. And letting that kind of chill down, get nice and cool. Bringing the tissue over. And taking the pestle out just so we can kind of see those larger chunks of tissue. And again, I'm going to kind of break those up a little bit just by kind of tamping down with the pestle into the mortar. Getting those larger chunks broken up into smaller ones. Okay, now I can start grinding. And when you get to the grinding portion, you probably don't want a whole lot of liquid nitrogen in the bottom of the mortar. Makes it a little bit more difficult if you have too much. You want to have enough in there to kind of keep things cold, obviously. But if there's too much liquid nitrogen in there, what will happen is the tissue particles will kind of start to float to the top, and it'll just be harder to grind that way. You want to kind of keep them closer to the bottom. So here you can kind of see I may have a little bit of residual tissue that's left on the pestle. So I'm going to pour some more liquid nitrogen in there, and I'm going to kind of continue to grind a little bit and just kind of swirl that pestle around to get all the residual off of there so that it's nice and clean. A little bit more liquid nitrogen. I typically don't put the styrofoam rack on the board. I'm just doing this for demonstration purposes. There you can kind of see me warming up the hinge before I pop the cap open on the tube that's been pre-chilled in liquid nitrogen. I'm going to add a little bit more liquid nitrogen here to kind of keep things cold. And swirl that around a little bit. Make sure I get all the tissue away from the sides. And now I'm bringing the pre-chilled funnel in, putting that on top of the microfuge tube. And having to add a little bit more liquid nitrogen. And swirl it around. It's evaporating, and yeah. So that's when you want to dump it, when it's just almost to the very end and all the liquid nitrogen is evaporated, but not quite. That's when you want to dump it into the funnel. And then I'm tapping that tube and funnel on the bench top to kind of get it to go down. If you have too much liquid nitrogen in that mortar and you go to pour it into the funnel and into the tube, what's going to happen is that liquid nitrogen is going to get in the bottom of the tube, and it's going to start kind of spitting and popping as it evaporates, and it can be pretty violent at times. And so what will happen is the tissue will actually blow out the top, and so you don't want that. So you want to make sure you've got as little liquid nitrogen left as possible. So there you can kind of see that I'm getting the residual tissue out of that mortar into the funnel and kind of tapping it again and making sure that that's all down in the bottom of that tube. And then I'll cap it, and there we go. There we go. That's it. So I'm letting that evaporate a little bit before I cap it, and so then that's going to go back into the freezer box that's in the styrofoam container. I just wanted to take a moment to talk about the two different grinding methods. You'll want to start with the coarse grinding method on the left-hand side, and you can see that I'm holding the pestle with the pestle in the palm of my hand using downward pressure to break up those larger tissue fragments. And once they're broken up into smaller pieces, then I switch positions and hold the pestle like I would a pipette and move in a circular motion to grind the tissue to a fine powder. So here are a couple of examples of the ground liver tissue sitting inside the mortar. Over on the left-hand side, you can see the small fragments kind of clustered together in the center. On the right-hand side, you can see another clustering there in the center. The red circle, you can see there are actually smaller fragments that are moving outward from that smaller cluster. And so you want to make sure that you're getting all of those tissue fragments collected and into the microfuge tube. And so you can see in the video that I did previously that I'm swirling the liquid nitrogen around in the mortar to make sure that I get all of the tissue fragments out of there. And it's very important that when you're pouring the liquid nitrogen into the mortar that you're doing it slowly. If you do it too quickly, what's going to happen is the liquid nitrogen is going to kind of splash around in the mortar, and more than likely what's going to happen is your sample will slosh out of the mortar and you're going to lose it. So you want to make sure that when you're pouring the liquid nitrogen in there to do it very slowly, and make sure you're not sloshing or splashing anything around. So here's an example of residual tissue that's left in the mortar after I have already made my first dump into the microfuge tube. And so you can kind of see on the right hand side it's outlined with the red circle. It's kind of difficult to tell, but there are some pieces of ground tissue there. And so in this case I would take some more liquid nitrogen, pour that up into the mortar, kind of swirl it around a little bit, and then pour that into the funnel to collect all of that tissue. As the dipper is in the liquid nitrogen for an extended period of time, what's going to happen is it will build up frost sitting in the bottom, and so you can kind of see there are like little white pieces, looks like kind of snowflakes floating in the bottom of that dipper. And so you want to make sure that you don't pour that into the mortar. You want to make sure that you kind of dump that out and then kind of skim the liquid nitrogen off of the top to avoid any kind of frost landing in the mortar because you don't want that added to your sample. Here are examples of what the tissue looks like after it's been poured from the mortar into the funnel. Over on the left-hand side, you can see a nice tight pellet has formed, and on the right-hand side, you can see where it's just fragmented pieces of tissue that are in the funnel. And so this is why it's imperative, to take the tube and the funnel out of the styrofoam rack and really tap it well on the bench top to get all of those pieces down into the microfuge tube. Here you can see that there are cutting fragments that are left over from our initial cutting of the sample prior to weighing. And so we want to make sure that we get rid of all these tissue fragments before we move on to the next sample. The polypropylene container will still be cold, and so all that's really necessary is to just take the container, invert it over a waste container and kind of tap that on the side, and all of those fragments will come out of there. If there are any smaller pieces that aren't knocked off, you can just take a Chem wipe and wipe that out before moving on to the next sample. Here's the finished ground tissue in the microfuge tube. After pouring the ground tissue from the mortar into the funnel and then down into the tube, and you tap the tube on the bench top to get all those fragments to move down to the bottom, it's important to let the tube breathe for about 2 to 3 seconds before capping it. You want to make sure that all of that residual liquid nitrogen has boiled off. If you don't and you cap it right away, what's going to happen is pressure is going to continue to build in that tube to the point where the cap will likely pop open, and you don't want that to happen. Also, you want to make sure that you're holding the tube by the top cap, not by the middle, and definitely not by the bottom of the tube where your sample is located. So now the tube is ready to go into storage at -70 or -80 until you're ready to do extractions. So this brings me to the end of my video. Hope you found it informative, and thank you.